Hello everyone, welcome to this complete machine learning course by HNM Technologies. Today we are starting one of the most exciting and fastest growing technologies in the world, machine learning. If you think about the applications we use every day, Netflix recommending movies, YouTube suggesting videos, Amazon recommending products, Google predicting search results, self-driving cars detecting objects, banks detecting fraudulent transactions, all of these systems are powered by machine learning. Machine learning is actually a subset of artificial intelligence, where computers learn patterns from data and make intelligent decisions. Instead of writing thousands of rules manually, we allow machines to learn from historical data and improve automatically. In this course we will learn machine learning from beginner to advanced level, using Python, which is the most popular language for machine learning. Even if you are completely new to machine learning, don't worry. We will go step by step and build strong foundations. Before understanding machine learning, we must understand how traditional programming works. In traditional programming, we provide input plus rules to output. For example, let us say we want to create a program that identifies spam emails. We write rules like, if email contains words like, win money, lottery, free offer, then classify as spam. But this approach has limitations, because there are millions of ways spam messages can be written. Writing rules for every case is almost impossible. The system becomes difficult to maintain. Now imagine analyzing millions of emails per day. This is where machine learning becomes powerful. Instead of writing rules manually, we allow the computer to analyze thousands of emails and learn patterns automatically. So the new workflow becomes data plus learning algorithm to model to prediction. The machine learns patterns from past data and uses that knowledge to predict future outcomes. Let us now define machine learning in simple terms. Machine learning is a technique where computers learn patterns from data and make predictions without being explicitly programmed. The concept was formally introduced by Arthur Samuel in 1959, who defined machine learning as the ability of computers to learn without being explicitly programmed. The key idea is learning from data. Let us consider a simple example. Suppose we have the following dataset: experience salary 1 year 30,000. 2 years 40,000, 3 years 50,000, 4 years 60,000. A machine learning algorithm studies this data and learns the relationship between experience and salary. Then if we ask the system, what will be the salary for someone with 5 years of experience? The model can predict an approximate value. This ability to learn relationships between variables is the foundation of machine learning. Machine learning is used in almost every industry today. Let us look at some important examples. Healthcare. Machine learning helps doctors detect diseases early. Examples: cancer detection from medical images, predicting heart disease risk, drug discovery. Finance. Banks use machine learning for fraud detection, credit risk analysis, stock market prediction. Example: if a credit card suddenly makes a large purchase in another country, the system may flag it as suspicious. E-commerce. Companies like Amazon use machine learning for product recommendations, demand forecasting, customer behavior analysis. When Amazon says, customers who bought this item also bought, that recommendation is generated by machine learning algorithms. Transportation. Machine learning is critical for self-driving cars, traffic prediction, route optimization. Companies like Tesla, Waymo, and Uber rely heavily on machine learning. Social media. Platforms like Instagram and YouTube use machine learning for content recommendation, face recognition, spam detection. Machine learning is generally divided into 3 major categories. 1. Supervised learning. In supervised learning, the dataset contains inputs plus correct outputs. These outputs are also called labels. Example dataset: study hours, exam score 250, 460, 670. The algorithm learns the relationship between study hours and exam score. Later, if we give a new value, study hours equals 5, the model predicts the expected exam score. Supervised learning problems are divided into 2 types. Regression. Regression predicts continuous values. Examples: house price prediction, temperature prediction, sales forecasting. Classification. Classification predicts categories. Examples: spam versus not spam, disease versus no disease, fraud versus legitimate transaction. Common supervised algorithms include linear regression, logistic regression, decision trees, random forest, support vector machines. 2. Unsupervised learning. In unsupervised learning, the dataset does not contain labels. The system must identify patterns on its own. Example: suppose we have customer data, age, income, purchase behavior. The algorithm automatically groups similar customers. This process is called clustering. Companies use clustering for market segmentation, customer targeting, product recommendations. Common algorithms: k-means clustering, Hierarchical clustering, DBSCAN. 3. Reinforcement learning. Reinforcement learning is inspired by human learning through trial and error. An agent interacts with an environment and receives reward for good actions, penalty for bad actions. Over time, the agent learns the best strategy. Applications include robotics, self-driving cars, game-playing AI. For example, the AI system AlphaGo used reinforcement learning to defeat world champions in the game of Go. Let us now understand the machine learning pipeline. Most machine learning projects follow these steps. Step 1. Data collection. Collect relevant data from databases. APIS, senses web scraping. Example, if we want to predict house prices, we need data such as location, size, number of rooms, year built. Step 2. Data cleaning. Real-world data often contains problems such as missing values, incorrect values, duplicates. Data cleaning ensures the dataset is accurate and usable. Step 3. Feature engineering. Features are the input variables used by the model. For example, in house price prediction, features could be house size, number of bedrooms, location, distance from city center. Selecting the right features significantly improves model performance. Step 4. Model selection. Choose an appropriate algorithm. Example, regression problems to linear regression, classification problems to logistic regression or decision trees. Step 5. Model training. The algorithm learns patterns from the training dataset. Step 6. Model evaluation. We measure how accurate the model is using metrics like mean squared error, accuracy, precision, recall. Step 7. Model deployment. Finally, the trained model is deployed in a real application such as mobile apps, websites, enterprise systems. Let us briefly look at one of the simplest machine learning algorithms. Linear regression predicts a relationship between variables using a straight line. The equation used is y equals mx plus b, where y equals predicted value, x equals input variable, m equals slope of the line, b equals intercept. Example, predict salary based on years of experience. The algorithm finds the line that best fits the data points. Python is the most widely used language for machine learning because it provides powerful libraries. Some important libraries include NumPy. NumPy is the core library for numerical computing in Python. It provides fast array operations, mathematical functions, support for large datasets. Think of NumPy as the foundation of all ML libraries. What is NumPy? NumPy is the core library for numerical computing in Python. It provides fast array operations, mathematical functions, support for large datasets. Think of NumPy as the foundation of all ML libraries. Why NumPy in ML? Used for feature matrices, mathematical transformations, vector operations. Pandas. Pandas is used for data manipulation and analysis. It provides two main structures: series, 1D, data frame, 2D table. Why Pandas? Easy data handling. Works with CSV, Excel, databases. Powerful data cleaning tools. Why Pandas in ML? Used for cleaning datasets, preparing features, data exploration. Matplotlib. Matplotlib is used for visualizing data using graphs. Visualization helps understand data patterns, detect outliers, interpret model results. Scikit-learn. Scikit-learn is the most popular ML library in Python. It provides ready-to-use algorithms, pre-processing tools, evaluation metrics. Why Scikit-learn? Easy to use, clean API. Supports most ML algorithms. Why Scikit-learn in ML? Complete ML pipeline, easy experimentation, industry standard. TensorFlow and PyTorch, used for deep learning applications. How to predict house prices based on property features. Main features are house size, number of bedrooms, location, year built, number of bathrooms. The algorithms used in this process. Linear regression and random forest regression. Similarly, we have lot of predictions. Email spam detection, movie recommendation system, customer churn prediction, credit card fraud detection, handwritten digit recognition, sentiment analysis, fake news detection, stock price prediction, image classification system, traffic sign detection, resume screening system, etc. Let's discuss in detail one by one. Problem statement. The goal is to predict the price of a house based on its features. Real estate companies use ML models to estimate property prices so buyers and sellers can make informed decisions. Example question: if a house has 2,000 square feet area, 3 bedrooms, and is located in a prime area, what will be the price? This is a regression problem because the output is a continuous value. Example dataset: size, square foot, bedrooms, age, location, score, price 1200 210 750,000, 1500 358 70,000, 1800 339 90,000. Input features: independent variables, house size, number of bedrooms, house age, location, score. Target variable: house price. Machine learning concept. A regression model tries to find the relationship between input variables and output value. The simplest model used is linear regression. The mathematical relationship is price equals F, size, bedrooms, age, location. The model learns patterns from historical housing data. Algorithms used: common algorithms, linear regression, random forest regression, gradient boosting, XGBoost. For beginners, linear regression is the best starting point. Implementation workflow. Step 1. Data collection. Housing datasets can be collected from Kaggle government property data real estate websites. Step 2. Data cleaning. Handle issues like missing values, incorrect entries, duplicate records. Example: if bedroom value is missing, replace with mean value. Step 3. Feature engineering. Create useful features. Example: price per square foot. Price per SQFT equals size, price. Step 4. Model training. Using Python. Here is the sample Python code showing on screen from sklearn. Linear_model import linear regression. Model equals linear regression, model.fit, x_train, y_train. The model learns patterns from training data. Step 5. Prediction. Example: model, predict, 2003, 5, 8. This predicts the estimated house price. Evaluation metrics. Regression models use metrics like mean absolute error, MAE, mean squared error, MSE, R-squared score. Higher R-squared means better predictions. Real-world use. Companies using similar models: Zillow, Redfin real estate platforms. Let's discuss about how spam detection will work. Here is the problem statement. The goal is to classify emails into spam or legitimate messages. Spam emails include phishing advertisements, scams. Machine learning models automatically detect spam. Example dataset: email text label, win a free iPhone now. Spam, meeting at 3 p.m., not spam. Label: spam means 1, not spam means 0. Machine learning concept. This is a classification problem. The model predicts a category instead of a number. Text processing, NLP, text data must be converted into numerical form. Steps: tokenization. Break text into words. Example: win a free phone. This text is going to split into multiple win, free, phone. Stop word removal. Remove common words, the isn't. Vectorization. Convert text into numeric vectors. Techniques: bag of words. TF-IDF. Algorithms used: common algorithms, naive Bayes. Logistic regression. Support vector machine. Naive Bayes works very well for spam filtering. Implementation using Python. Example code is showing in the screen from sklearn. Feature_extraction, text import count vectorizer. From sklearn, naive_Bayes import multinominal NB. Steps: first convert text to vectors, second train classifier, finally predict spam probability. Evaluation metrics. Classification models use accuracy, precision, recall, F1 score. Spam detection prioritizes high precision. In the real world used by Gmail, Outlook, Yahoo Mail. Sentiment analysis is used to understand human emotions from text data. For example, Amazon reviews, Twitter comments, YouTube feedback, customer support messages. All of these can be analyzed to understand whether users are happy, unhappy, or neutral. Sentiment analysis is a technique in natural language processing, NLP, used to determine the emotional tone behind a piece of text. Types of sentiment: positive, negative, and neutral. Examples: this product is amazing, is a positive. Very bad experience, is negative. It is okay, is neutral. Why is sentiment analysis important? Businesses use sentiment analysis to understand customers, analyze feedback to improve products. Brand monitoring, track public opinion about a company. Social media analysis, understand trends and user reactions. Decision making, make data-driven business decisions. NLP basics for sentiment analysis. Before applying ML, text must be processed. Step 1. Text cleaning. Remove punctuation, special characters, numbers. Example: great product, smile. 2. Great product. Step 2. Lowercasing. Convert all text to lowercase. Step 3. Tokenization. Break text into words. Example: I love this phone. Split into multiple string array. I love this phone. Step 4. Stop word removal. Remove common words like the, isn't. Step 5. Stemming or lemmatization. Reduce words to root form. Example: running. 2. Run. Better. 2. Good. Converting text to numbers. Machines cannot understand text directly. We convert text into numerical form. Bag of words. Counts frequency of words. Example: I love ML. I love AI. Vocabulary: I love ML, AI, machine learning models. After converting text into numbers, we apply ML models. Common algorithms: first, naive Bayes. Fast. Works well for text. Second, logistic regression. Good accuracy. Simple to implement. Third, support vector machine. Powerful for classification. Here is the advanced models. LSTM, deep learning, transformers, like BERT, in the screen showing sample Python code for implementation. To evaluate model performance, accuracy, precision, recall, F1 score. For sentiment analysis, precision and recall are very important. In this real-world applications, sentiment analysis is used by Amazon for product reviews, Twitter for trend analysis, YouTube for comment filtering, customer support for feedback analysis. Companies analyze millions of reviews automatically using ML. Hers is the conclusion: machine learning enables data-driven decisions. Real projects improve learning. Practice with real datasets. Build the projects and publish on GitHub. Thank you for choosing HNM Technologies. For more videos, please subscribe.